What's up guys, and welcome back to Mathematical Mindset. So right here guys, we have this ninth Olympiad math problem and we are to find the value of x. So the first thing guys we want to do is to apply the property of exponent that says if we have a raised to the power of m plus n, this is equal to a raised to the power of n multiply a raised to the power of n. So we're going to apply this property to the left hand side of this equation. So we have this to be 4 raised to the power of x plus 25 raised to the power of x is equal to 10 raised to the power of x multiplied 10 raised to the power of 1. Alright, so we have this to be 4 raised to the power of x plus 25 raised to the power of x is equal to 10 raised to the power of x multiplied 10 raised to the power of 1 is 10. So the next thing that you want to do right now is to simply divide both sides by 10 raised to the power of x. So we have this to be 4 raised to the power of x divide 10 raised to the power of x plus 25 raised to the power of x divide 10 raised to the power of x, and this is equal to 10 raised to the power of x multiply 10 divide 10 raised to the power of x. But from the property of exponents, if we have a raised to the power of x divide b raised to the power of x, this is equal to a over b or raised to the power of x. So applying this property, we have this to be 4 over 10 or raised to the power of x plus 25 over 10 or raised to the power of x is equal to this. We cancel out this, so we have this to be 10. So we have this to be 4 can be expressed as 2 multiplied 2 divide 10 can be expressed as 2 multiplied 5, and this is raised to the power of x plus 25 can be expressed as 5 multiplied 5 divide 10 can be expressed as 2 multiplied 5, and this is raised to the power of x. This is equal to 10. So we have that this we cancel out this, so we have this to be 2 over 5 or raised to the power of x plus this we cancel out this, we have this to be 5 over 2 or raised to the power of x, and this is equal to what? 10. But we know that if we have a over b or raised to the power of n, this is equal to b over a or raised to the power of negative what? N. Alright? So applying this, we have this to be 2 over 5 or raised to the power of x plus we have this to be 2 over 5 or raised to the power of negative x, and this is equal to 10. But if we have a raised to the power of negative n, this can be expressed as 1 divide a raised to the power of n. So we want to apply this property right here. So we are going to have this to be 2 over 5 or raised to the power of x plus 1 divide 2 over 5 or raised to the power of x, and this is equal to what? 10. So from here we're going to say let 2 over 5 or raised to the power of x be equals to m. So then we have this to be m plus 1 over m, and this is equals to 10. So we look for the LCM, we have this to be m, this is over 1 divide m is m times m, we have this to be m squared plus m divide m, 1 times 1 is 1, and this is equal to 10. So you cross multiply, we have this to be m squared plus 1 is equals to 10 multiply what? M. So we have here to be m squared plus 1 is equal to 10m. So the next thing we want to do is to simply rearrange and set this equation to 0. We have this to be m squared minus 10m plus 1, and this is equals to 0. So we are going to solve this quadratic equation by making use of the quadratic formula. So we have the quadratic formula to be given as m is equals to minus b plus minus the square root of b squared minus 4ac divide 2a, where we have a is equal to 1, b is equals to minus 10, and c is equals to 1. So we have that m is equals to minus multiply minus 10 plus minus the square root of b square, which is minus 10 all square, minus 4 multiply a, which is 1, multiply c, which is 1, divide 2 multiply a, which is 1. So from here we have this to be m is equal to minus times minus is plus, so we have 10 plus minus the square root of minus 10 whole square is 100 minus 4 multiply 1 is 4 divide 2 multiply 1 is 2. So m is equals to 10 plus minus the square root of 100 minus 4, we're going to have 96, and this is going to divide 2. So m is equals to 10 plus minus the square root of 96 can be expressed as 16 multiply 6, and this is going to divide 2. But we know that if we have the square root of a multiply b, this is equal to the square root of a multiply the square root of b. So m is equals to 10 plus minus the square root of 16 multiply the square root of 6, and this is going to divide what? 2. So from here we have that m is equal to 10 plus minus the square root of 16 is 4 root 6 divide what 2. So m is equal to, if you factor out 2, we have this to be 5 plus minus 2 root 6, and this is going to divide what 2. So this we cancel out this, we have that m is equal to 5 plus minus 2 root 6. So we have that m is equals to 5 plus 2 root 6, and we also have that m is equal to 5 minus 2 root 6. So we have been able to find the values of m. So we want to simply recall, at one point we said let m be equal to 2 over 5 all raised to the power of x, alright? So we want to make use of this equation. Let's call this equation star. So we want to recall equation star. So we're going to say recall from equation star, we have that m is equal to 2 over 5 all raised to the power of x, right? We have this to be 2 over 5 all raised to the power of x is equals to 5 plus 2 root 6. We are actually working with this equation right here. So from here, the next thing we want to do is to take the log of both sides. So taking the logarithm of both sides, we have this to be log 2 over 5 all raised to the power of x is equal to log 5 plus 2 root 6, okay? So from here, we want to apply the logarithmic property that says if we have log a raised to the power of b, this is equals to b log a. So we have x log 2 over 5 is equal to log 5 plus 2 root 6. So we want to divide both sides by log 2 divide 5 to isolate x. So dividing both sides by that, this is going to cancel out this. So we have that x is equal to log 5 plus 2 root 6 divide log 2 over 5. But we know from the logarithmic property, if we have log a divide log b, this is equals to log a base b. So applying this, we have that x is equal to log 5 plus 2 root 6 base 2 over 5, and this becomes the first value of x. So we have been able to solve this part right here. The next thing we want to do is to solve for m equals to 5 minus 2 root 6. So we want to simply recall what m is. We know that m is equals to 2 over 5 all raised to the power of x. So we have this to be 2 over 5 all raised to the power of x is equals to 5 minus 2 root 6. So the next thing we want to do is to simply take the log of both sides. So taking the log of both sides, we have this to be log 2 over 5 all raised to the power of x is equal to log 5 minus 2 root 6, okay? So from here, we have this to be, if we apply this logarithmic property that says if we have log a raised to the power of b, this is equal to b log a. So applying this property, we have this to be x multiply log 2 over 5 is equal to log 5 minus 2 root 6. So divide both sides by log 2 divide 5 to isolate x right here. So doing that, we have that this we cancel out this. So we have that x is equals to log 5 minus 2 root 6 divide log 2 over 5. So we want to simply apply this logarithmic property that says if we have log a divide log b, this is equals to log a base b. So applying this property, we have that x is equal to log 5 minus 2 root 6 base 2 over 5, and this becomes the value of x. So we have been able to find the value of x right here, and we have our answer right here. So guys, this is how you can solve this nice math Olympiad problem, and we already have the values of x. We have that x is equal to log 5 plus 2 root 6 base 2 over 5. This is the first value of x, and we also have log 5 minus 2 root 6 base 2 over 5. So these are the values of x. So with this guys, I'm going to see you within the next video, and if you are not yet subscribed to Mathematical Mindsets, please do it, click onto that subscribe button and give this video a thumbs up.